We'll be starting again with the part which is called as the hydrology. Hydrology is what? The study of water for hydroelectric plants for the generation in under power system. Hydrology. Already we have seen that the study of the water, in that we have seen the runoff, which is actually the water which is actually flowing after the precipitation minus evaporation. So R is equals to precipitation minus evaporation. We have already seen this formula. This is an important formula on this formula you can have some objective type of questions in examinations. Please remember this formula. So we'll start with hydrograph. The graph between the discharge of the water with respect to time is called a hydrograph. So this hydrograph can be of annual basis, on the monthly basis, on the weekly basis, on the daily basis. So the time can be in a decade also. So for our time is not a constant here, but the discharge is very much important. The discharge is actually in meter cube per second. So this is very important. The discharge versus time is called the hydrograph. We have also seen that the power generated is equals to QWNH, where the power is directly proportional to the height of the power plant. And we know that one more thing, that the flow duration curve, but obvious the discharge will be giving me the flow duration curve. For annually, if I talk about in the January, it will be average, then it will be lessen up up to May, it will be very much less, and when the rain starts, then in the June almost it is on the peak, then July on the peak, almost August, then it will start coming down, and it will take an average value, and up to the December it will be on the average value again, almost equivalent to January, and it will be minimum in almost April, May. So we have the flow duration now for our annual curve. That flow duration is actually also called as the mass curve or the load duration curve, because more the water flow, more the discharge. As we have seen, the discharge is directly proportional to the power generated, so that will be equivalent to your load duration curve. So we'll be discussing that load duration curve in a short while. So we'll start with the classification of the hydroelectric plants. We'll start with the classification of the hydroelectric plants. How the classification of the hydroelectric plants are there. So it is normally based on three parts, which is called quantity of water available, and on the basis of the head, which we have discussed about earlier also, on the basis of the availability of the head, and the third is the nature of the load. So on the basis of three, I have first, as I already said, is on the quantity of water. How much water is available? So on that, I can have several number of plants, the runoff river plants without pondage. Without pondage means as the water comes into the river, I can have this is my river, and since there is no way such that I can have a reservoir behind my dam, so I can have an arrangement where water is flowing from here, and this is my power plant. It's also going into that. There is a turbine, there is a generator. From generator, it is electricity is coming, and the water again goes into the main stream. This is one way of the river runoff river plant without pondage. I can have a different arrangement for this. That my actually water flowing is in this direction. I can have a canal from here. The water will be flowing into it. I have a construction of the dam, and the dam will be having a turbine as well as here the generating station, and for generation will be going here, and water will again come here, and it will come again into the mainstream, and it will flow like this. So I can have this arrangement also. Since I don't have arrangement of the reservoir behind my dam, so I can have two type of hydroelectric plants, and the quantity of water available is one of the water. One is called a runoff river plant without pondage, and one is called a runoff river with pondage. So runoff river without pondage are these type of plants where we don't have an arrangement of the reservoir. So reservoirs are not there. So one can normally see this thing that whenever water is coming into the picture, whenever water is coming here, or in the previous figure we have seen that the water that the generation plant was in between your stream. So it was like this. Your generation plant is here, water is coming from here. After generation is again going to the mainstream, like that. So whenever water is coming here, it will definitely pass through this, and it will definitely generate an electricity. That is for sure. But the thing is that whether the discharge of the water behind this small generating station is always constant, no, because every time the water availability of the water will not be there. This is for very small station, and the thing is that it is always dependent on the availability of the water. As soon as the May comes or the water is less, so this generating station will not be working properly. As soon as the July or August comes, the rainfall is high and the flow of water in the stream is high. At that time, we will be having this type of generating plants working very fine. But in the case when it is March, April, May, it will not be able to withstand that much of. It will not be having that much of capability of delivering that much of power which is required. So these are plants are used as the water comes. As the water comes in them, they are used, and when the water availability is not there, so they are not used. So these plants have a very low efficiency in the sense of time. They are not reliable at that much reliable as a normal hydroelectric plant with the pondage are. So we can consider another that with pondage, I can have a pond behind it. I can have an arrangement such that the water is flowing here, and I can have one pond here, and after that I have my generation dam over here, and after that it is again going into the stream. So in this manner I can have water collected over here, and the water which is being collected over here, it will be used for future use when in the dry season, when normally the water is coming, we are producing the electricity. When the water is not coming, we are having some water, so that we will be able to produce the electricity whenever we are in requirement. So these type of plants are little more reliable than the without pondage, because since the pond is very small, so the reliability of these are not very much high, but it is high in comparison to without pondage plants. Coming to another part which is called as the reservoir plants. A reservoir of plants. Since the water available at the reservoir or the storage of the reservoir will be very much high in comparison to the with content and without content. Even in the dry season, even when it is May or June, when the water is not available from rain and from the streams, then also the production of the electricity with reservoir plants are very much high because they reserve their capacity of the water, and whenever there is a dry season the water is passed through the turbine and you get the electricity, and during the rainy season they are actually collecting the water, and according to the load they are dispatching or they are discharging the water. So the reservoir plants are much more reliable, and the efficiency of the reservoir plants and the capacity of the reservoir plants are much more than the with pondage and without pondage type of plants. Coming to another part which is called the availability of the head. We have seen how much head is important when we are talking about the production of the power. So on the basis of availability of head, we can have three different arrangement again. One is the low head plants, another are called the medium head plants, and third are called the high head plants. So here also I can have three different plants. One is called the low head plants, another is called the medium head plants, and lastly they are called as the high head plants. What is the difference between low, medium and high head plants? So when we are talking about the low head plants, when the head of the plants are less than 30 meters, it is called the low head plants. When it is greater than 300, then it is called the high head plants, and medium head plants are normally considered at 30 to 300 meter plants. So these are on these basis which we will be having the classification on the basis of head, low, medium and high. Apart from that, I can have some more discussion about this after a short while. On the basis of the nature of the load. Nature of the load is very important. There are different type of load. That one is called the base load, and which is always available, even normal average, which is for a consumer, that all the consumer are at least this much of consumer will be always there present, and then normally we can see that we have a different load schedule for that day also. We are normally we are sleeping at night, so we have the load at the night is very much less when we are talking about the normal private customers, and the load is very much high during the evening period, because in the evening normally everybody is using tube lights, electricity, the fan, TV, the washing machines and all that. Normally everybody is using when they are awake. But when we are sleeping in the winters, we don't require a fan, we don't require anything. So at the winter seasons, normal commercial users have, normal private users are very less. But in the commercial reason, electricity is always used, even in the daytime also, even in the night time also. So we have a normal average of the load which is always present, that is called the base load. So we need to have a plant which is always producing the electricity for the base load plant. So we have, on the nature of the load, we can have a plant which is called the base load plants, another is called the peak load plants. So suppose for a city, suppose 100 megawatt is the normal plant, normal load of the plant, and so every time the generating plant is committed to produce 100 megawatt of electricity, but during the peak hours, approximately 80 megawatt are supposed to be taken out of other stations or from my different interconnections. So total number of electricity generation or total number of electricity required at that period will be 180 megawatts. So 180 megawatt is the peak load, suppose. So that is supposed to be supplied from some other station, and that we will be discussing that why it should be supplied from some other station rather than from the same station. And so for till now, for understanding, we can understand that the baseload plants are the plants which are normally every time they are in the circuitry, where otherwise the peak load plants are those which are normally not in use, but whenever there is a requirement of the peak load, they are put into the interconnection so that they will be supplying the additional load which is coming. And apart from that, one more plant is called the pump storage plants, which are in the hydroelectric plants only. We have pump storage plants also, which are normally and are under the peak load plants only. We'll be discussing this pump storage plants in a short while.